This is problem 130 of Neetcode 50, insert intervals. In this problem, we're going to be given an array of interval. And at each interval, so each position within this array, we are going to have two values, a starting one and an ending one. We're going to be given intervals that will initially be sorted in ascending order, and they will be free of overlaps. What we're also going to be given is a new interval with a starting and an ending value. Our task is to insert this new interval inside the intervals such that it is still in ascending order and that we don't have any overlapping values. So what is an overlap? If we take a look at this here, okay, we have two intervals, 1, 2, and 2, 3. An interval basically has an overlap with another interval if one of its value appears inside the other's interval. So for example, here the second interval starts with a 2, but a 2 appears in the first interval. So this doesn't work. This should basically become 1 to 3, right? Because there's an overlap with these two. So let's go see the example 1 where our given intervals are 1, 3, followed by 4, 6. The new interval is 2 and 5. We can say right away that 2 and 5 seems to appear between any interval that we have. So what we're going to do is that we're going to go see the first index of this new interval and see where exactly it fits inside our already existing interval. We're going to see that it fits exactly inside this first interval 1 and 3, meaning that there won't be any need anymore to keep this value true because this value 2 because we know it is going to exist inside this interval already. So what we're going to do is that we're going to basically change this new interval value for the minimum between its current value and the first index of this first interval in which it lies. So the minimum value is going to be a 1, and this is why in the output we see a 1. Now we're going to go see the second index of this new interval, which is a 5, and we're going to realize it lies in the second interval of our set intervals. And what we will do in this case, since it fits right in the middle of this, and we are not going to need to keep this 5 anymore because it is already contained inside this interval. So what we're going to do is that we are going to take the greatest value between this 5 and this 6 and keep it. That's the reason in the output we see that we only have a 1 and a 6. If we take a look at a more obvious example here, we have a set of intervals 1, 2, 3, 5, 9, 10, and a new intervals 6, 7 that has no overlaps with the previous interval. So we're just going to insert it between the 3, 5 and the 9, 10. So this is quite an obvious example. Now let's go see the recommended time and space complexity. They suggest us to have a time complexity of big O of n and a space complexity of big O of 1. If we take a look at the solutions proposed by Neetcode, all of them actually have a space complexity of big O of n. In this tutorial, I will show you how to have a real space complexity of big O of 1. So let's go on a whiteboard, and now I will make some cleanup. All right, so let's say that we add the intervals 1, 2, 3, 5, 6, 8, and 9, 10. And the new intervals we're given is 4, 7. We know that there is an overlap with the previous interval. Okay, so what we will do is that we will try to put a pointer to where exactly is the first intervals where there is an overlap. So to do so, we will first check the first index, or the index at the position 1 of the interval, and we're going to compare this with the index at the position 0 of our new interval. This is the new, okay? Just making sure. And these are our intervals. All right. Great. So if the value at the index 1 of our interval is smaller than the value at the index 0 of our new interval, we know that there won't be any overlap. And this entire interval will go before the new interval. So we don't have to worry about this. We will take a look at the next index, well, the next interval, and we will compare its second value again with the first value of our new interval. This time it won't be smaller. So this is going to indicate us that we now are going to start our overlaps. So we're going to put our index I, and we're going to basically let it here. So we have a marker of where the overlap starts. And we're eventually going to have basically an ending pointer G that will basically tell us where the overlap stops. And an overlap stops when and only when the index at the position, well, the index 0 of the interval is greater than the index 1 of the new interval. See, the 9 is greater than the 7. So we know that this entire interval will go after our new interval, and there won't be any overlap. So now we know that the only problem is this. It's this range from I to G. So what we will do is that we will go see basically all the first index. So we have a 4, we have a 3, we have a 6. And we will modify the new interval's first index to be the minimum value between each of them. And we will do something quite similar for this. So for the index 1, so we'll go see the index 1 of each of these overlapping interval. And we will set the first index of this new interval to be the greatest value of each of them. 3. So it's going to be 8. And then what we are going to do is that we are going to erase everything that is between I and G. And I erased too much here. So I had a 2 here. I had a 0 here. So what we're going to do is that we're just going to place our new index, which now contains basically the new interval that has no overlaps and that has the new interval insert in it. We're going to place this right there. And this is going to become the answer. So this is going to become the new interval sets when we add the new interval in it. Notice that by doing this, we added the new interval in a way that now all the intervals are in increasing order and they don't have any overlap with each other's. And also, since we're just updating the position, we are not creating an additional array. We're going to have a space complexity of big O of 1, a real one, not like those proposed in Neetcode. So let's go ahead and code this. So what do we need? At first, we need an index I, and we need n. Well, we don't really need n, but n will be my helper. So I will just set n to be the len of intervals, because I feel like it is quite long to write the len intervals every time we need to use that. So I will just put this in n. Great. Now I'm going to be willing to place this I index at the first interval where there is an overlap, meaning that if there is no overlap, I will just move it to the right. So I will do this by saying while I is in range, of course. This is something that we need to keep into our consideration. And then while basically the interval at the index I and at the index 1, so the last value of this particular interval, while this is smaller than the new interval's first value, index 0, we know that there is no overlap, and all the values of this particular interval are smaller than the values of this new interval, meaning that this is not where we want to put our I pointer, so we're just going to move again. When we break this loop, we are at a position where our I is going to point to the first interval where there is an overlap with the new interval. So what I will do is that I will let this I be at this position, and then I will keep moving forward with our G. And then I will be creating a while loop while G is in range, with the goal to reach the last interval's index where there is an overlap with our new interval. So basically, this is gonna happen if, there will be still an overlap in the interval if the interval's first position, so if the first position of the intervals that follows the one we already looked at, if this is smaller or equal than the new interval's second value, we know that we have an overlap. So what we will do is that we will set this new interval's index 0 to be equal to the minimum between the new interval at the index 0 and the interval's G's first value. All right, just like we saw in our example. And then the interval at the index 1, instead of being the minimum, it's going to be the maximum, the new interval at that particular position. Forgot to close my bracket here. And that is shown bracket here. So the interval at position 1 is going to become the maximum value between that particular that position itself and the interval's second value. So the index G at position 1. And then we can say G plus equal 1. So we move our pointer G. And when we break this loop, it means that the first value of this interval is actually greater than the last position of the new interval, meaning that there won't be any overlap. And all the values after this index G, well, all the intervals after this index G will be strictly greater than this new interval, and they will come after. So what we will do, now that we have basically our index I position at the first place where there is no overlap, and that we have an index G position at the last position where we have an overlap, and that we have a new interval that basically accounts for all the overlaps, what we will do is that we will set the intervals from index I to G to be equal to the new interval. So this is how we replace it. And then we can return the intervals. So if I didn't do any mistake, this should run perfectly. Takes a while. Excuse me for the wait. But while it's taking its time, I want to make you realize that we didn't create any additional space. So we have an actual big O of 1 space complexity. And also we have a big O of n time complexity because we're going through every single interval inside our intervals. So with that being said, that's my solution. I hope you enjoyed the video. I hope you learn, and I hope to see you in the next one.